All right, let's talk about a problem that I know keeps developers up at night. You're trying to export a massive amount of data from a Python API, but your server only has a tiny bit of memory. If you've ever had that sinking feeling watching a server just die trying to send a big file, then this explainer is definitely for you. Okay, let's get into it. Man, this really hits home, doesn't it? Your API is just humming along, everything seems fine, handling all the normal traffic, and then some user clicks export, and the whole thing just blows up. Our first instinct is always, we need a bigger server, more RAM. But here's the thing, the problem isn't the hardware. It's the way our code is fundamentally designed to handle the data in the first place.
So I want you to think about this like we're on a deep space mission. Your API, that's our ship, and its one critical mission is to deliver this huge, super valuable payload, your data, all the way across the internet to the user. But this payload is heavy, and our ship is small. To pull this off, we're going to need a completely different kind of engineering.
And look, we're not talking about petabytes here. You don't need a whole Spark cluster for this. We're talking about a couple of gigs. It's this really awkward middle ground. It's way too big for a simple request, but it feels too small to bring in the heavyweight big data tools. And that is exactly why so many production APIs quietly fail in this exact situation. So what happens to our mission? It's a catastrophe. Our ship, the API, tries to cram that entire 2 GB payload into its cargo bay, its memory, all at once. The hull can't take the strain, the ship just implodes, and mission control, the out-of-memory killer, has to terminate the process. The payload is just lost forever in a black hole of memory errors. Let's pull up the schematics of our faulty ship. Most Python frameworks, like Flask and Django, they kind of nudge you towards this buffering model. You hit the database, it gives you back this giant list of results. You build that list in memory. Then you serialize that whole thing into one massive JSON string, also in memory, and only then do you finally send it. It's simple, it's intuitive, and for large files, it is completely, fundamentally broken. And this flawed design leads to 3 different system failures hitting you all at once. First, your RAM usage just goes through the roof because you're holding the entire dataset in memory, maybe even twice, once as Python objects and then again as that giant JSON string. Second, your user is just sitting there staring at a loading spinner for what feels like forever. The time to first byte can stretch into minutes because the server can't send a single thing until the whole payload is ready. And third, the process handling this is totally blocked. It can't serve anyone else, and your whole system just grinds to a halt. And this right here is the critical takeaway. This isn't some rare, exotic edge case. This is a super common failure point for any API that needs to export reports or logs or transaction histories. It's a silent killer because it almost never shows up in testing. It waits until you're in production with real data sizes to rear its ugly head.
So what is the answer? Well, it's a total paradigm shift. We have to stop thinking about our API as a script that just runs and spits out a result. We need to re-engineer it from the ground up to be a pipeline that flows data from the source directly to the user, one piece at a time. So here it is, your new mission directive, your call to action. Stop buffering. Just stop. If your job is moving a big chunk of data from point A to point B, you have to start thinking like a pipeline. You need to stream. Now, the core technology for our new ship's engine is the Python generator. A normal function returns a value and it's done, but a function with a yield statement is different. It yields a value, and then it just pauses. It holds its state, waiting for you to ask for the next one. It produces data piece by piece over time without ever needing to hold the whole dataset in memory. This is our new data flow engine. Okay, mission accepted. Time to head down to the engineering deck and get our hands dirty. We're about to refit this API. We're going to transform it from a fragile little cargo ship into a robust data streaming vessel that can handle any size payload we throw at it. Let's get to work. Now, this fix isn't just one line of code. It's a coordinated upgrade across 3 different layers of our stack. We've got to tweak the application code itself, change how we format the data for transfer, and then adjust the server infrastructure that's actually hosting our API. First up, the application layer. In a framework like Flask, you're going to stop returning a big list. Instead, you'll wrap your generator function inside a response object. That's the signal to Flask to start streaming. And this is critical. You have to pull data from your database incrementally. Forget about using methods like .all, which grab everything at once. You need to use tools like SQL Alchemist's yield_per that are designed to fetch rows one by one, so you don't accidentally memory bomb your own API from the database drive. All right, now for a hidden bottleneck that trips up so many people. JSON serialization. Python's built-in JSON library just wasn't built for speed. When you're processing thousands and thousands of rows, that one step can become the slowest part of your entire request. The solution? Swap it out for a high-performance library like OR.json. It's written in Rust, and trust me, it gives you a massive speed boost. And I mean, the performance difference is just staggering. Look at this. In a simple test, OR.json is over 8 times faster than the standard library. When you're yielding data row by row, every little bit of speed counts. And these micro-optimizations add up to huge savings in your total response time. It just makes your whole data pipeline flow so much faster. Next up, we have to choose the right format for our payload. You know, a giant JSON array is incredibly fragile. If that connection breaks halfway through, the whole file is corrupt just because that one closing bracket is missing. A much, much better format for streaming is NDJSON, or New Line Delimited JSON. Each line is its own complete, self-contained JSON object. This makes the stream incredibly resilient. If it fails, the client still has all the valid records it received up to that point. And finally, the infrastructure. Look, Flask's little development server is not going to cut it. You need a production-grade server like Unicorn, ideally with async workers like Gevent, so we can handle lots of connections at once. And here's the big gotcha. If you're using a reverse proxy like Nginx, you must turn its proxy buffering off. If you don't, Nginx will just sit there and buffer your entire response before sending it, which completely defeats the whole purpose of streaming. And just like that, our ship is refitted. The mission is a success. The payload gets delivered, the server stays stable, and our user is happy. We've gone from a world of breaking things to a new frontier of flowing data. So let's just quickly summarize the core lessons from our journey. This right here is the single most important thing to remember. When you switch from buffering to streaming, you change your memory usage from O of n, where it grows right alongside your data size, to O of 1, which is constant memory usage. What does that mean? It means your tiny 512 megabyte API can now serve a 200 megabyte file or a 20 gigabyte file using roughly the same tiny amount of RAM. This is the key to real scalability.
So, to recap the keys to our success. First, Python generators are the engine that makes that constant memory usage possible. Second, the streaming architecture itself turns our slow black box API into a responsive, transparent pipeline. And third, the NDJSON format makes sure our data delivery is resilient and can survive network failures.
So here's the bottom line. If your backend is still building giant lists in memory and just crossing its fingers, hoping for the best, it's already broken at scale. The modern approach is to see your backend not as a server of static data, but as a conduit that efficiently flows data from where it lives to where it needs to go.
Hey, if this mission debrief helped you think about your own API architecture in a new way, you should definitely consider subscribing to Lolly Official. We do deep dives into real-world engineering challenges just like this all the time. And if you found this valuable, do me a favor and give this explainer a like and share it. You probably know at least one other engineer who's fighting a memory monster right now. Thanks so much for joining the mission today. I'll see you in the next one.